Hi all, welcome to KANA's 100 Days 100 Test series. So in the video, we will see the chapter Electrostatic Potential and Capacitance based questions. There are 45 questions, so we'll solve them one by one. So first given is that there is an electrical charge, it is placed at so and so point, and then at the point, another point like let's say this one is P1, and this is P2. So we need to find at P2 how the electric potential will be, electric field, and how it varies in the space. Okay, let's see how to solve this question. So the first given is that Q is so and so coulombs, and then let's say the point P1 is 1, 2, 4 meters, and at P2 it's 4, 2, 0. So this means this is x1, y1, z1. So this is x2, y2, and z2. All right. So first we need to find the distance. So just with the three-dimensional coordinates internal, so the distance between P1, P2 is okay square root of x2 minus x1 whole square plus y2 minus y1 whole square plus c2 minus c1 whole square. So we have x1, x2 values, so on y and z values. So the substitute we'll get it as 3 square plus 0 square plus 4 square. That is nothing but 5 meter. So we have the distance. So the formula pata V is equal to K Q by R, while electric field is nothing but it's K Q by R Q, but R is actually over here. So direction it's from charge to point. Okay, so now V could be, so we know this K value is 9 into 10 power 9. Okay, and then we have Q as 2 into 10 power minus 6. Okay, and then R is 5 meters. So if we substitute all of this, we'll get it V as 3600 volts. Okay, we have one of them. Okay, அடுத்து we need to see the direction of E vector. So E vector or direction எப்படி இருக்கும்? Resultant R ஓட இது எப்படி இருக்கும் பார்த்தீங்கன்னா, so it is like 3 I coordinate it's 3, and in J coordinate it's 0. So it will be the resultant R vector is like 3I minus 4K ன்னு இருக்குமா? So அப்பனா எதுனா, so there is no component that is not along the y-axis. That is for sure, because y-axis it's 0 work. So that's one point. First point is we know about the voltage and electric field about it. Then in dielectric medium, third point, in dielectric medium, okay, so this E, it decreases. Why do you think that it decreases? Because E is equal to medium by K. So it is divided by the K factor. So it will decrease. So based on this option, so this is not definitely true, will be along y-axis, because resultant vector, I mean, even from seeing here you can see that it will get cancelled out, 2 minus 2. So this is not possible at all. Electric field will increase in கொடுத்திருக்காங்க points of the dielectric, so we will eliminate these two options for sure. Actually then all of the above is also not possible, because if these two are valid, this is not there. But here in the question, it is a typo. This should have been like 3600, sorry, 3600 volts, not 36 volts. But this is the closest answer we could derive. அடுத்த question. There are three identical charges. They are placed at corners of an equilateral triangle of side L. The force between any 2 points charges F. The work required to double the dimensions of the triangle is what in கேட்டிருக்காங்க. So we need to find the work required basically. So here it's based on equilateral triangle, right? So we need to so there are three identical charges. They are at corners of equilateral triangle. Okay. Side of the it's L. Let's say F is the force between any pair. Okay. Then if the force between any two charges is F, the work required to double the dimensions of the triangle. So what if the triangle side is doubled? So side becomes 2L. Okay. So this is given part. Let's see how to solve this. So U is equal to, for three charges, this is three charges, right? Three charges will be sum of pair energies. So this is nothing but 3 times Q by K square by L. And they're given F is equal to K Q square by L square. Okay, so this implies K Q square equals to FL square. Okay, so let's say this is equation 1, this is equation 2. So initially U1 will be, initial UN will be 3 times this KQ square by L. Based on this part, you can write it as FL square by L. So it will be 3 times FL. So finally, similarly, final side, it is 2L. Okay, so U2 will become 3 times K Q square by 2L. So the further simplify again, it will become 3 by 2 times FL. So work required is del U is can be written as U2 minus U1. Okay, so U2 is what? 3 by 2 FL minus 3 FL. So FL common value எடுத்துக்கலாம். So it will be 3 by 2 minus 3. So 1.5 minus 3 will be minus 1.5. So there's nothing but minus 3 by 2 FL. Yeah, this is the answer. So it's option C. Okay. Next one. So it's a electric potential based one. At point P, there is R distance away due to a point charge Q. At a point A is V. Electric potential is given as V at distance R due to a point charge Q. If twice of this charge is distributed uniformly on the surface of a hollow sphere of the sphere radius of so and so 4R at the center of point A, the potential at P now is what and get it done. Okay, so here the concept is that inside spherical shell potential is constant. And what is that value will be K Q times radius of the shell. Okay, so based on this, so nu V will be after the radius will be K 2Q. Okay, because charge is also getting twice. So K2Q by radius is 4R. So it will be KQ by 2R. So KQR is the original one. Now it becomes KQ by R. So it will be B by 2. So new V is B by 2 of original one. Okay. Another question. It's again two concentric spheres of radii. The inner sphere has charge 1 microcoulomb and the outer is this one. They are of same sign. The potential is 9000 volt at a distance of 3R from the common center. The value of R is what? You get it. Okay, so there are like two concentric spheres. Let's say this is R and let's call this as 2R. There is a point at some point and the potential is like 9000 volt and this distance is 3R. Okay, so inner one has 1 microcoulomb and outer one has 2 microcoulombs. So you need to find this value of R basically. Okay, so இதுக்கு potential formula என்ன? V is equal to K Q total by R. So Q total will be 3 microcoulombs. Okay, at R equals to 3 capital R, 9000 equals to, we'll just apply to this original formula. So V is 9000 and we know K is 9 into 10 power 9 and Q total is 3 into 10 power minus 6 coulombs. Okay, all of this divided by 3R. So எல்லாமே numbers, we have only one variable, that is R. So we need to solve for R. So this will be R is equal to so we'll bring R to one side and then we'll solve for it. Okay, so R becomes 9 3s are 27, 27 into 10 power 3. So here it will be 3 into 9000, right? If you solve all of this, you'll get it as 1 meter. Okay, so the answer is 1 meters. So this distance is like 1 meter. So this is 2 meters and this is 3 meters. Okay, another question. Electric potential and an electric field is given as so and so V is equal to K by R. At position vector, then electric field will be what? I'm going to get it now. Okay, so V is given as K by R at R is equal to this vector. Okay, so we need to find the electric field. So electric field oda formula என்ன முன்னாடி பார்த்த மாதிரி, so it will be K times R by square. So this is nothing but K vector direction by R cube. Okay, so இதுதான் formula. So first magnitude of R பார்த்தோம் அப்படின்னா it will be 2 square plus 3 square plus 6 square, right? Position vector base பண்ணி. So magnitude of R will be 7. அப்போ R cube will be 343. Okay, so இதை plug in பண்ணோம்னா it will be, so we can eliminate all the other three options because only this one has a denominator of 343. So either way we can solve it. Anyways, so we have another way how to confirm it also. If the position vector அப்படியே தான் இருக்கான்னு பார்க்கணும். It's 2i plus 3j plus 6k அப்படியே தான் இருக்கு and then k factor இருக்கு. So this is the right option. Okay, another question 6. So they have given v of x in this equation. it's 1000 by x plus 1500 by x square plus 500 by x cube. I need to find E at x is equal to 1 meter. So formula in the question can Ex is equals to minus dV by dx. Okay. So if we differentiate this equation, it will become minus 1000 by x square minus 3000 by x cube minus 1500 by x power 4. So by E of Ex will become negative of this, negative of this whole, right? That's negative of dV by dx. So this was dV by dx. So negative of all this. So E of x will be positive 1000 by x square plus positive 3000 by x cube. It's power 4. So at x is equal to 1, this will become equal to 1. You will be 1000 plus 3000 plus 1500. This will be 5500 volt per meter, and this is positive x. Okay. So the answer is it's B, because they have given the key here is it's at any point x, y and j are 0. So in the y and j component, actually this is also, I mean, like if you use a logic, இதை சால்வ் பண்ணாமலே எப்படி இன்னும் ஃபாஸ்ட்டாக சால்வ் பண்ணலாம். I mean, இந்த இவ்வளோ calculation பண்ணாமலே சால்வ் பண்ணுறதுனா one more thing is like they're given x point, but the y and j axis are 0. ஸோ ஆப்ஷன்ஸில் எங்கே y and j இருக்கோ அந்த காம்போனன்ட்ஸ் எல்லாமே not y and j. I mean like j and k இருக்கோ, because this is j and this is k, right? So எது இருக்கோ அந்த ஆப்ஷன்ஸ் எல்லாமே எலிமினேட் பண்ணிடலாம். So this j and k will get eliminated. And இங்கேயும் k இருக்கு, ஸோ அதனால் இதுவும் this also will get eliminated. So you can easily select the option B. Next question. The potential at a point x, it is measured in micrometers due to some charges situated on the x-axis is given by so and so. The electric field at x is equal to 4 micrometer is given by what? I didn't get it on. So V of x is 20 by x square minus 4. X is in micrometers. So we need to find E at x is equal to 4. Okay. So similar situation. So E is equal to minus dV by dx. So this will be negative times dV by dx will be 20 times minus 1 divided by x square minus 4 whole of plus 2, because it's in denominator already. Then it will be 2x times. Okay. Then going to simplify panna, it will be negative 40x divided by square minus 4 the power whole of 2. Then E can be written as, I mean at x is equal to 4, E can be, F4 will be 40 times 4 by 16 minus 4 whole square. So it will be 160 by 144. So this is 10 by 9 volt by micrometers. 10 by 9 volt by micrometers in your end equation. Okay. So one is there is given as in the negative x direction, another one is in positive x directions. So but here x will be in positive x directions. Okay. Okay, அடுத்த question. There are three concentric conducting spherical shells carrying charges so and so. The charge on the inner sphere of the outer shell will be what in get gone. Okay, so the key rule here is that the change on inner surface of a conductor equal to the net, sorry, I mean the charge. The charge on the inner surface of a conductor is nothing but negative times the net charge inside the cavity. Okay, so first, what is the net charge inside the outer shell? It's nothing but 4q plus 4q plus minus 2q. So that will be 2q. Okay. So then inner surface of outer shell will be opposite of this because negative, so it is negative of 2q. Okay. Next question. Okay. There are inner shell A has a positive Q charge and while B is earthed. So what are the facts here? So the induced charge பார்த்தோம்னா the induced charge on inner surface of B. Inner surface of B is equal to minus Q. So in the inner surface எல்லாமே it will become minus so on so. Sorry, negative. Okay. So that is negative Q. Since B is earth, outer surface charge becomes 0. So in the earth connect outer surface charge will be outer surface of B charge is 0. So net enclosed will be plus Q minus Q. That will be 0. If charge is 0, then E is also equals to 0. Okay. So charge on the outer surface of the B is 0 ன்னு சொல்லியிருக்காங்க. Yes, we said that. அப்போ இது right. The charge on the B is equal and opposite to A. Yes, that's also right. It becomes negative charge. Field inside A and outside B is 0. Yes. இங்கேயும் there is no field inside and then field outside also is 0. So it's the all of the above. 10th question. Okay. So there is a right isosceles triangle. They have given the distance between the sponsors A and there are charges like Q plus Q and there are two plus Q's and then one capital Q charge. If the net electrostatic energy of the configuration is 0 if Q is equal to what and get gone. So we need to find that what charge of Q this net electrostatic energy becomes completely 0. Okay. So distance between plus Q, I mean two charges is A. So between Q and the left plus Q is, this should also be A. Right, because it's right isosceles triangle. And this distance between Q and plus Q will be A times root 2. Okay, so we have all the distance. இப்போ formula போனோம்னா it's like total energy is total energy U is equal to K Q square by A, the first one, okay, plus then we have this component, so it will be Q by A plus then we have this one, it is Q by A root 2. So we need to find what point like net electrostatic energy is 0. So when U is equal to 0. So when U is equal to 0, it will be Q square plus Q capital Q into 1 plus 1 by root 2 equals to 0. So if you solve for Q, it will be Q is equal to negative Q times 1 plus 1 by root 2. Then further simplify it will be minus Q times root 2 by root 2 plus 1. So that's option B. I guess I think we can further simplify this in another form as like write this also as negative 2 times Q by 2 plus root 2. So it is option B. But it's a typo, I guess they missed the Q here. Yeah. 11th question. There is uniform E along the positive X direction. There is uniform E along positive X axis. So the rule here is that E is minus dV by dx. So what happens? It's like means the potential it decreases as X increases. Okay. So there is they say uniform electric field in X direction, A be the origin and B to the point on the X axis at B is equal to 1 centimeter and C on the Y axis at Y is equal to 1 centimeter. So there are, so this is let's say origin, this is A and B is here, that's like 1 and C is such that it's 1, 1, okay. So we have this point, okay. So then the potential at points A, B, and C. So we need to compare the potential at VA, VB, and VC. Okay, the potential decreases as X increases. Okay, so at V, VB is less than VA. Okay, because the distance increases, so VB is less than VA. That is for sure. Okay, at C, Y on the plus 1 centimeter, but X is 0. So what happens? We are worried about the X only, not the Y. So VC will be equal to VA only. Okay, does not done the Y here. So VC is equal to VA. So apana in the option eliminate pannidalam. Then when we compare VB and VA, the most suited one is this one, option B. The question. Two isolated, there is a charged conducting spheres of radii A and B. They have the same electric field near the surfaces. The ratio of electric potentials on the surfaces is what? So there is a same E near surfaces of sphere. They have radius A and B. Okay. So for sphere, direct formulas always. So E is equal to, so I mean, first understand what is given and what is asked, then go directly for formulas. So K E equal to K Q by R square. What does it mean? So Q is directly proportional to R square. V பார்த்தோம் அப்படின்னா it is KQ by R. So what does it mean? V is directly proportional to R. So what does it happens to the ratio then? V1 by V2 becomes A by B. Okay, so in terms of radius. So it will be option A. Okay, next is 13th one. So potential difference between S1 and S2 is proportional to charge on S1. So what does it mean? Likely is that the conducting shell S1 having a charge Q surrounded by an uncharged concentric spherical shell of S2. The potential difference between them is V. If the shell S1 is now given a charge of minus 3Q, the new potential difference between the same two shells is what? Okay. So in the conditions, it's important to understand that the potential difference between S1 and S2 is proportional to charge on S1, right? Okay. So S1 initially as positive Q given negative 3Q additionally. So new charge will be positive Q minus 3Q. It will be negative 2 times Q. So if it is a charge, new charge is becoming like minus 2Q. So what about the del V then? Del V also becomes negative times 2V. So it's option D. Okay, at a certain distance from point charge, so it's a, okay, the field intensity is given and potential is given. The distance from the charge and the magnitude of the charge respectively. So we need to find the R, the distance, as well as the magnitude of this point charge. Okay. So we know that E is equal to magnitude of electric field is nothing but H by R. So this means R is equal to V by E. Okay. Magnitude of R will be like V by E. So this will be 3000 by 500. So it will be 6 meters. So that is straightforward. Okay, we could eliminate only one option. So anyways, upon charge can be. So then Q is equal to what? V R by K, right? Because V is equal to KQ by R. So if further simplify, it will be like negative 3, sorry, negative 3000 into R is 6 meter. Here it will be 9 into 10 power 9. So the further simplify, it will be negative 2 times 10 power. It will be negative 2 times 10 power minus 6 coulombs. So it is like 2 microcoulombs, but it will be negative. But here question is they are asking only about the magnitude. So we don't have to worry about this negative charge. So it is, the answer is it's 6 meters and the 2 microcoulombs. Okay. Then hollow sphere based question. Potential at the center is V, then same. So the potential at center equals V. It is same everywhere inside. Okay. So when the surface potential will be Q by R. So Q is equal to VR by K. So for R is greater than this capital R, then E equals becomes K Q square by, sorry, Q by R square. Okay. So you can write this as Q by R square V R by K. So this can be simplified as V R by R square. V R by R square. So that's option E. Next question. So it's work done based question. So work done can be written direct formula. So work done is nothing but Q ES and cos theta. Okay. So they've given work done as 4 joules and charge is 0.2 here, and then the okay, we need to find the E. So let's keep E as it is, and this is given as 2 meters resistance. So 2 into cos theta, so cos of 60 degree. Okay. So the further simplify panamma, E will be 4 by 0.2. So it will be 20 per coulomb. Yeah. So it is this one. 17th. Okay. So it's there are 2 thin wire rings, each having radius R. We are placed at a distance d apart with their axes coinciding. The charges on the rings are plus q and my negative q. The potential difference between the centers of the 2 rings is what? Okay. The potential at center potential at a center of a ring V is kq by r square plus x square. Okay. Again, in the question left, this question is specifically the centers are separated by d. So the difference between centers, so V1 minus V2 is 2 kq into 1 by r minus 1 by r square plus d square. Okay. So either further simplify it will be, I'll simplify like again further write it down as y epsilon minus 1 by r plus 1 by r square plus d square. Okay, corresponds to option D. Okay. Next question. There is a charged capacitor. The separation between the plates of a charged parallel plate capacitor is increased. Okay, D is increased, and the force between the plates becomes what and get it on. Okay. And let's assume this is an isolated charged plate. So force between the 2 plates will be Q square by 2 epsilon A. So do we see any distance in this in this formula? No. So there is no D. So that means it's independent of the distance between the plates. It depends on the charge, on the medium, and the area. So it does not depend on the D. So it remains the same. So then 19th. So they have given V of X is so and so. So it's similar to some questions we saw back. So it is 8x plus 5. Then E is equal to negative times dV by dx. Just all this, we'll get it as negative 8. So then the magnitude of E will be 8. Then charge density on the plate is 1 times E. So that is 8 times 8.85 into 10 power minus 12. Okay, so this is roughly 7.48 times 10 power minus 11. So it is option A. Okay, then 20th question. So இதுக்கு potential function கொடுத்துட்டாங்க. Then electric field at point, they are given some point position. So we need to find the electric field at this point. Okay, so V is equal to given as y square plus 2.5 xy negative 3.5 xyz in volt. So E is nothing but negative times this will be. So we need to find for every axis. So dV by dx will be, so for example, if you need to find the Ex, we need to do dou V by dou x. So the fundamental will get this equation becomes 2.5 y negative 3.5 y z, and they are given the point is at 1, 1, 1. So if we substitute இதுக்கு 1, 1, I mean like 1 values போட்டோம்னா y and z respectively, we will get it as negative 1. So we know that E of x is nothing but negative times dou V by dou x. So it will become positive 1. Okay. So we can eliminate this option. Okay. We don't even need to solve y and z components. Direct away we will go for this one because already x we found it as 1. Bare values irukku. But anyways, still we'll go ahead with the other components as well. Okay. So அப்படி பார்த்தா then we need to find ey, அது எப்படி கண்டுபிடிக்கிறது, அதே மாதிரி v by dou y போகணும். So it will be 2y plus 2.5x minus 3.5 xz. Similarly, at the point 1, 1, 1, this will become positive 1. Upper E of y will be negative of this. This will be negative 1. Okay. So we have Ex as so we have E in terms of x, y, and z. So x is positive 1. And here in y it is negative 1. So this also matches here. Okay, அடுத்து z component. Okay, so it will be dou v by dou z. So the differentiate part it will be minus 3.5 xy. So at 1, comma 1, this will be negative 3.5. So EZ will be positive 3.5. Will be positive 3.5. So this is the electric field values. So it will be this option. Next question. So potential at a center of a charged insulating sphere V0, then potential at its surface is what indicated on. So for insulating solid sphere, V center will be 3 by 2 times KQ by R, and V surface, it will be KQ by R. Okay. So if you write a V surface in terms of VO, it will be K cube by R can be written as V center. So V center equals 3 by 2 times V surface. So here V center is nothing but VO, so it is 3 by 2 V surface. So V surface is nothing but 2/3 of VO. Okay, 2/3 of VO. So here V center is nothing but VO. Okay, other question. There are the plates of capacitors are joined together by a conducting wire. So then அதோட capacitance எப்படி இருக்கும் அப்படின்னு கேட்டிருக்காங்க. So we are joining the plates by wire. So it makes the V as a 0, but the charge flows. But as you know, capacitance depends only on geometry. Okay, it remains unchanged. Okay, 23rd, it's a assertion reason based question. First, try to read the assertion. The distance between parallel plates of a capacitor is halved. Dielectric constant is made 3 times. Then the capacitor becomes 6 times. Okay, let's first try to understand what happens in the conditions. So C is nothing but K times epsilon A by D. Okay, so D is half. So so if D is halved, the C will become 2 times increase, right? So it will increase 2 times. K is tripled, that seems. If K is tripled, C would increase again 3 times. Okay. So then the capacitor becomes 6 times, right? Because it's 3 into 2. So it will be yes. So C becomes 6 times. So the assertion statement is true. But the reason says the capacity of the capacitor does not depend upon the nature of the material. So this is totally wrong. முன்னாடி பார்த்த questions சொல்லலாம். If we solve that right, you know this is false. So let's see, assertion is true, but the reason is false. Next one. இதுவும் assertion reason based question. So there is a parallel plate capacitor. It's connected across battery through a key. A dielectric slab of constant K is introduced between the plates. The energy which is stored becomes K times insulation. Okay. So first let's try to understand the assertion. So battery connect ஆனா battery is connected V is constant. So then we insert dielectric. So C increases by K. So the capacitance increases by K. So energy U is half CV square. So new thing will be, it will be K times half C V square, because C is, this is old C, new C will be like K times that of old C. So it will be overall energy increases by k times. So this is true. The surface density of charge on the plate remains constant or unchanged. So this is false because the charge density is Q by A. This increases. Why? Since Q is equal to C times V, so it increases. So as C increases, Q increases. So if Q increases, surface density of charge also increases. So in the question, statement 1 is true, but statement 2 is false. Okay, we match the following. So the similar charge close. So the change in potential energy when distance between the similar charges decreases. Okay, so when similar charges are closer, similar charges are brought closer, this means U increases. It becomes positive. Okay, so that will be this one. Will be positive electrostatic potential energy. Okay, it has been given as positive. Then at the statement, the change in potential energy when the distance between the opposite charges decreases. So opposite charges. Similarly, when opposite charges they brought closer, you become more negative. So it's this one. Okay, so this will be B and this will be A. Next one, electrostatic potential energy develop. So P can be maybe positive, negative, or zero. Any of this can be applicable. But electric potential at infinity patha, it will become as 0. Okay. So final option is B. 26 from typical figure. This one here. So Q where there is positive Q at ends and there is some Q at center as well. We need to find the potential energy of the system. First distance is N to center. A button 2 pairs. But N to N pata, it will be QA, it's 1 pair. Okay. So we need to find the U. So U is equal to K times positive Q times negative Q by A. This one, positive. Yeah, because it's a negative times here, right? Yeah, that's why it's negative times QA and plus again negative Q times positive Q by A plus positive Q times positive Q by 2A. Okay. Yeah. Then so bracket here If the simplify பண்ணா it will be K times Q square by A negative Q square by A plus Q square by 2A. So it will be, sorry, here also negative Q. So it will be negative 2Q square by A plus Q square by 2A. So if you simplify this further, it will become negative 3 by 2 KQ square by A. So it's option B. Okay. Next question. It's based on closest approach. Closest distance approach. Okay. So when closest distance approach, what happens when KE converts to potential energy? So it is half mv square okay. So here is they saying that if Q were given a speed of 2v, so it has increased from speed v to 2v, or this case will be. Okay, so then it will be half m 2v square becomes 4 times half m v square. Okay, so then what happens if this becomes like the here? So R would become what on the relation because it's this is inversely proportional to R. So if it's increased 4 times, this has to become like decrease, I mean, by 4 times. It becomes R becomes R by 4. Yeah. Next question. Okay. Work done in slowly moving an electron of charge E and mass M from A to B along a semicircular path. This is the path. Vertical plane, the field of charge Q is what? So we need to find the work done phase. So this is a conservative field. Okay. This is a conservative field question. If the electron moves on a semicircle centered at charge Q, its distance from Q is constant. So its electron's distance from Q is constant. This means potential is the same at A and B. Okay. Upper del V becomes 0. So if del V is 0, what is the work done by this electrostatic field is that will also become 0. So here key is that in the conservative field and the question identify panita, you can easily deduce this answer to 0. Another question. Two electrons are moving towards each other, each with the velocity of this. What will be the closest distance of approach between them? Okay, முன்னாடி பார்த்த question மாதிரியே தான். So V is given as 10 power 6 meter per second. So kinetic energy will be what? It will be half m v square. Okay. But here it's a total kinetic energy is total kinetic energy is because there are 2 electrons. So it will be 2 times half mv square. It will be mv square because it's half mv square plus half mv square. And so it's 2 times. So its total kinetic energy is mv square at closest R mv square equals K E square by R. Okay, so you equate this total kinetic energy with this energy component. So R can be written as K E square by mv square. Okay, so the numerator denominator solve பண்ணலாம். So numerator will be K E square, so it's 9 into 10 power 9 into E square is 1.6 into 10 power minus 19 square. The solve பண்ணா will get it as 2.304 into 10 power minus 28. Now the denominator mv square is 9.1 into 10 power minus 31 into v is 10 power 6 in square, so it is 10 power 12. It will be 9.1 into 10 power minus 19. So we can divide this 1 by 2. So 1 by r is nothing but 1 by 2. So it will be 2.53 10 power 10 meters. Yep. அடுத்த question. 30th one. A point charge Q is surrounded by, there are 8 identical charges at distance r as shown in figure. How much work is done by the forces of electrostatic repulsion when the point charge at the center is removed to infinity? Okay. So the central Q, it interacts with 8 surrounding charges. Okay, and they are all identical at a distance of r. So this distance is like r. Okay, so the initial interaction energy is what? Initial interaction energy with center U is 8 times kq square by r. Okay, so this is initial one. So we need to remove from center to infinity. So the interaction becomes what? So we remove this center to infinity. So when it's to infinity, this will become, interaction becomes 0, right? So because if naturally r becomes infinity, this entire internal energy will become 0. So this is 0. So what is the work done by electrostatic forces is equal to decrease in potential energy. So that is nothing but 8 kq square by r minus 0. So that will be 8 kq square by r kq square by r. So that's option B. So here k is nothing but 1 by 4 pi epsilon. Okay. Next question. 31st. There are 4 charges at the corner of side A. So this is square of side A. Okay. And there are 4 charges at the corners. And then diagonal distance if you come, it will be A root 2. Okay. Yeah. So we need to find the work which is required to be done to make an arrangement of these 4 particles. And they all have positive Q. Okay. அப்படின்னா U is equal to kq square 4 times, it will be 1 by A plus 2 times, there are 2 diagonal interactions, right? That will be 2 times 1 by A root 2. Okay. The further simplify பண்ணா kq square by A common எடுத்துடலாம். So it will be 4 plus 2 can be written as root 2 into root 2. So this will get cancelled. Only root 2 will be left. So it is kq square by A 4 plus root 2. Option A. At the statement based questions. So question. So the first statement says that negative of work done in bringing the Q charge from infinite to point slowly without change in kinetic energy in electric field is called potential energy stored in charge Q. Okay, so what is a potential energy stored U? It is nothing but it's the work done by external agent bringing charge slowly. So this work done by electric field is negative of U. Okay, so statement 1 is true actually. When you compare statement 2, work done by electrostatic force in bringing Q charge from infinity to point, it's called potential energy stored in. Yeah, this is not the case. It's actually false. This statement is false. This is the right one. It's negative of U, work done is. Okay, so it's A, statement 1 is true, but statement 2 is false because the key here is negative of work done. 33. Determine the electric field strength vector. V is given as this. Okay, and it depends on only the x and y coordinates like that. So V is 10 A x and y. So E can be written as V. So it will be E x direction. It will be negative x and uy will be dv by dy. So here it will be, as it is negative of things, so it will be first we'll add negative, then 10. A will be constant as it is. So x all differentiate panna, it will be y is left here, and here it will be negative 10a, x will be left. Okay, so common is ex plus uy na, it will be 10a, negative 10a. So it's x plus, or like, sorry, y plus x. So y on the, it's in x direction and x is in j direction. Okay, so option is B. Next question. Okay, this is also similar to previous question. V is equal to 4x square and at a point is given. So you have to find the electric field. E is nothing but dv by dx. It will be negative times 8x. Yeah, it's negative dv by dx. So it's x now, so it is along I vector. So along negative, because it's a negative, so it will be negative x-axis. So there are two negative x-axis here and here, but it is 8 or 16. Magnitude பார்த்தோம்னா it is 8. So it's option A. Assertion reason based question. Assertion என்ன சொல்றாங்க? So there is electric potential at a point P, which is r distance away from negative Q charge can be positive potential. Reason says that electric potential is a scalar quantity. Okay. So for a single charge, negative Q, V is nothing but negative Q times R. So it's going to be always negative. Okay. So this is false. It cannot be positive potential at all. Next reason is that electric potential is a scalar quantity. This statement is true. but it's not the correct explanation of A. So final option will be D. A is false, but our statement is true. Okay. 36. Considering a group of positive charges, which of the following statement is true? So here, all charges are positive. So potentials add positive. So what does it mean? Sorry. So if all charges are positive, the potentials will also add positive. It cannot be zero at a finite point. So this potentials cannot be zero at a finite point. That's what I was trying to say. Okay, let me get back to the question. Yeah. Okay. So let me rewrite this. So all charges are positive. So potentials, they add positive. They cannot be zero at a finite point. So that is the key. This finite point. Okay. But this E is a vector. It can cancel to become zero. Okay. So the final answer will be option A. The net potential of the system cannot be zero at a point, but net electric field can be zero because it's a vector. 37. So when a test charge is brought from infinity along the perpendicular bisector of an electric dipole to the center of the dipole, then work done is what? And get it on. So on perpendicular bisector of the dipole, potential is zero. It was to zero everywhere. So bringing the charge from negatives and from infinity to center will be zero. So work done will be 0 2. Okay, so work done is given. So generally work done is Q times V2 minus V1. So here work done is given as 50 joules of work. Q is 2 coulombs. And it is given as negative 10 volt. Okay, the value of V is what? Okay, so it will be 2 times V negative of negative 10. Okay, so the solve on it will be 2 times V plus 10. So this will be V is equal to 15 volts. So option C. Next question. 39th. So there is option of, so this is also like energy conservation based. So of mv square q del v. So v is directly proportional to square root of q. Okay. So in terms of speed here, so this is speed or velocity. So VA by VB is square root of by 4Q, because it's Q by 4Q. So it will be 1 by 2. So it's option A. So the key on in the relationship now. Okay, another question. A charge Q is placed at each corner of a cube of side A. Potential at the center of the cube is what? And get it on. So potential V is 8 times KQ by R. So 8 and K can be written as 1 by 4 pi epsilon Q, and R here is, it was placed at the corner. So corner of a cube. So it will be R is 3/2 A. Okay. Further simplify பண்ணா yeah, we have to further simplify this stuff and we'll get V as 4Q by 4Q by pi epsilon O times √3. So it is this one. Okay. So here key is that this relationship V is nothing but A times the that of KQ by R. So how we got this? Since the potential is a scalar quantity, the total potential energy at the center is it's due to the sum of potential of all the potential due to all the charges. Okay. Next question, 41. So there are n small drops of same size are charged to V volts each. They coalesce to form a single large drop. Then its potential will be what? So for a drop, one drop, V is K Q by R. So if there are n drops and identical drops, it will be Q total will become n times Q and R new will be or Rn will be n times into the power of 1/3 times R. Okay. So V new will be, so this is an important relationship you should know. In the electrostatic based questions, I mean electric field based questions, because this will apply. So R becomes like cube root of n times R and Q total is n times Q. So then V new will be simply K n Q by n 1/3 times R. So this would be n power 2/3 K Q by R. Okay, K Q R will stay, it's only the n component, it's coming like this. So up and now n power 2/3, this K Q R is for individual V. So it is Vn power 2/3. Okay, next question. There is a positive ring and there is a test charge. It is released along positive X. So the potential decreases with X. So V of X becomes KQ times R square plus X square. So U becomes QV. So it decreases. So if this decreases, kinetic energy increases due to conservation of energy. So kinetic energy increase in ortham, that means speed has to increase. Okay. then its speed, how it will be? It should increases continuously. Yeah. Another question. So inside the conductor, so this is based on the concept that inside the conductor, potential is constant. So surface potential is 100 volts. Okay. And which of the following is right? Okay. This one, it's not a complete question. So let's skip this one. But the key here says it's option B, but the diagram is incomplete. But we can solve this in a way that, let's say this is V1 and this is V2. So we need to find whether if it is V1 is greater than V2. Okay. So அப்படி பார்த்தோம் அப்படின்னா then it makes sense because of the relationship between the V and the R. However, so I assume, so like from the diagram alone, like in the மற்ற எதுவுமே கொடுக்கலனாலும் still we can interpret it as like, so let's say this is V1 and this is V2. So relationship between like R versus V. Okay, so this is like a inverse relationship, right? So the distance R here, R is distance. So as that's how we can interpret the answer for 44 probably. Okay, next one. Work done in bringing the positive Q charge from infinity to the center of dipole along the equatorial line is 0. Statement 2, in the given figure, 1 is a variation of electric field with respect to distance for a point charge, while 2 is a variation of electric potential with respect to distance for a point charge. So first let's evaluate statement 1. So statement 1 is work and bringing positive Q to center of dipole along equatorial line is 0. Actually, along the equatorial line, the potential is 0, right? Potential 0 na, so work done also be 0. So this is true. In statement 2, graph 1, it's like E versus R, right? For a point charge. So E1. So 1 is electric field and 2 is V versus R. So as E is inversely proportional to R square, V is inversely proportional to R. So E falls faster. So it's a correct identification. So E falls much faster. Yeah. So statement 2 is also true. Both the statements 1 and 2 are true. Okay. So the question how to identify them is like which falls faster. Like this is because it's 1 by r square. This is only just 1 by r. So on the mathematical knowledge irundhuchu appadina, it's easy to solve this question. Okay, that's it from my side. Thank you for watching this video. Have a good day.